Hello, Year 11. I hope that you are well. As you can hear, I have a bit of a croaky voice, which is why I'm not at school today. But if you listen carefully, hopefully we can get through this theory together and you can keep going with your work. So today we are talking about the radian measure of an angle. Up until now, we have always measured angles in degrees. And then there is minutes and seconds as well, but they are all part of degrees. There is another way of measuring angles, which is the radian measure. Now, to describe a radian measure, we have this little description here at the top of your page. Angles may be measured in three different ways. We can use degrees, radians, or gradients. In this course, we only use degrees, which we're already familiar with, and we have this new one to learn about, which is radians. It is important to have your calculator in the correct mode when using trigonometry, because sometimes you're going to be doing calculations in degrees and sometimes they're going to be in radians. So on your calculator, let's have a quick look. If you have a look at the very top of your screen, you will hopefully see that there is a little D there. That stands for degrees. All the trigonometry you've done in the past uses degrees, so that is perfect. But if we're going to use radians, we need to press Shift and then Mode to bring up that menu. And you'll see the number 3 says degree. That's the one we're used to. If we put it into 4, you'll see that at the top of your screen it changes to a little R, which means that your calculator is now in radians and ready to do work in radians. Okay, so just be careful with using your calculator, making sure it's in the right mode. The size of an angle in radians is defined as the ratio of two lengths in a circle. The angle with the vertex O, constructing a circle with the center O meeting two arms at the angle A and B. Now that's very, very wordy. But what it means is the size of the angle in the diagram over here, this angle over here, would measure 1 radian if the sector that we have cut off there with two little radiuses, that the length of AB is also the same length as the radius, obviously just curving. Okay, and so that is how a radian is measured. So in triangle AOB, the arc length, sorry, not triangle, that should be angle. Angle AOB is equal to the arc length of AB divided by the radius AO. If you consider a full revolution, the arc length is also equal to the circumference. So this is how we get our little formula to convert between degrees and radians. One whole revolution is equal to the circumference, and if we divide that by the radius, we get this formula. Circumference is 2 pi r, the radius is r. The r's will cancel out, and that means that a revolution is equal to 2 pi degrees. A revolution is 2 pi radians. A revolution is 360 degrees, so we have 360 degrees is equal to 2 pi in radians. Now that's just a little bit of where it comes from. We just need to be able to use that. So the next section is called Degrees and Radians Conversions. Degrees are written using the degree symbol. For example, 30 degrees has 30 with a little degree symbol in there. Radians are calculated by finding a ratio of the arc length to the radius, such as they have no unit. So you won't see a little symbol for them. But often you will see the pi symbol in there, which is how you will identify that they are a radian. So you're encouraged to memorize the ones in the table here. We've already talked about the first one. 360 degrees is equal to 2 pi radians. If we halve both sides, that means 180 degrees is equal to pi radians. And that one is the one that we base most of our conversions on. And finally, if we halve that again, 90 degrees is going to be equal to, halving the right-hand side, pi over 2 radians. So to convert from radians to degrees, you're going to multiply by 180 over pi. Or the simplest thing to do is to replace the pi with a 180 degrees. If you want to go the other way from degrees to radians, then you're going to multiply by pi over 180. Now, to help you remember that, I've drawn a little diagram over here on the side in blue. So you can see I've got degrees. If I want to go to radians, you follow the arrow and you're going to times by pi over 180. If you're at radians and you want to go back to degrees, if there is a pi in the question, the simplest thing to do is to just replace the pi with 180 degrees. So that's the sub 180 for pi that I've put there. The other option is occasionally they will give you, even though it's in radians, it will be as a decimal number. So in that case, you can't really replace the pi. So instead, you're going to have to multiply by 180 over pi. So it's also interesting to note that a 1 radian is equal to 180 degrees over pi, which is approximately 57 degrees and 18 minutes. Okay, so that's 1 degree, almost 60, one radian, sorry, is almost 60 degrees. 1 degree is equal to pi over 180, which is equal to 0.0175 radians. Okay, so here are the questions. It's just converting, learning to convert between the two things for the main part of these questions here. So question 1, express the following angles in radians. So these angles are all in degrees. So to go, if you go back to my little chart here, if to go from degrees to radians, we're going to times them by pi over 180. So for each one, I'm just going to go times pi over 180, like that. Now we want to leave these in exact form. We don't want to go to a decimal unless it tells me to. So what I want to do is I want to simplify the 60 and the 180. So you could go, right, that would be a 60 over 1, which means I can cancel, divide by 60 to get 1 here, and divide that by 60 to get a 3. And that then gives me 1 times pi, which is pi on the top, and 1 times 3, which is 3 on the bottom. The other easier way to do that is simply to type in your calculator the 60 on the top and the 180 on the bottom. Get your calculator to simplify the fraction for you, and you just know you need to put a pi on the top. So it's going to be 1 pi or pi over 3. Let's try that again. So for part B, to turn that into radians, I need to times by pi over 180 degrees. So let's do the easy option this time. Let's do the 240 over 180. Get the calculator to simplify it down. So it's 4 over 3. So my answer, I just put the pi on the top, 4 pi over 3. Then part C, I do the same thing. So I'm going to times by pi over 180. Use your calculator, type in the 535 over 180, and simplify the fraction down, and I get 107, put the pi on the top, over 36. And one more time, 29 degrees. To turn it into radians, I'm going to times by pi over 180. Type in the fraction, 29 over 180. It's not going to simplify, so it's going to be 29 pi over 180. Question 2 is going in the reverse direction. It says to express these angles, which are all in radians, because you can see all those pi symbols in there, and we want to put them in degrees in exact form. So remember, there's 2 ways to go from radians back to degrees. If there is pi's in the expressions, which there are in this one, all you need to do is replace the pi with a 180. So that becomes 180 over 3. 180 divided by 3 is 60 degrees. Let's do it again. Replace the pi with 180, so it's 180 over 6, and that equals 30 degrees. Let's do it again. replace the pi with 180 and divide it by 4. That's equal to 45 degrees. And one more time, replace the pi with 180 will be 3 times 180 over 5. And that is equal to 108 degrees. However, the second way, question 3, express the following angles in degrees. So these numbers here are going to be in radians, and we want to convert them into degrees to 1 decimal place. Now, the reason this is different is because there's no pi's in these questions. So the other option is that we multiply that by 180 over pi, and we type that into our calculator. So 0.25 times by 180 over pi equals, so to 1 decimal place, that is 14.3 degrees. Next one, same thing. To convert that into degrees, I need to times it by 180 over pi, and just type that into your calculator. So 30 times 180 over pi is very, very big angle, because 30 radians is very, very large. So that's 1718.9 degrees. So question 4, we've practiced converting from degrees to radians and radians back to degrees. So question 4, we want to apply this to some situations that we've used in the past. We want to find the exact value of some trig expressions here. So for most people, we're most comfortable working in degrees. So the easiest thing to do is, first of all, to convert your angle into degrees, and then do the methods that we've learned earlier in the year. So that's what I'm going to show you to do here. The first question is cos of pi over 3. Pi over 3, remember to change that into degrees. You replace the pi with 180, so it's going to be 180 over 3, so that's 60 degrees. If I want to know the exact value of 60 degrees, that comes from the exact value triangle, which looks like this. This is on your formula sheet, and we'll probably need the second one as well, so I'll draw that while I'm at it. Okay, so cos of 60, go to the 60-degree angle. Cos is adjacent over hypotenuse, so that's a 1 over 2. So the exact value of cos pi over 3 is a half. Let's try it again. Sine of 5 pi over 6. First of all, let's see what that is in degrees. Replace the pi with 180. So 5 times 180 over the 6 is equal to 150 degrees. So that's sine 150. Now that's, of course, an obtuse angle, which is in the second quadrant, somewhere out here. We want to find the reference angle, or the acute angle. So we would do 180 minus 150, which would tell me that acute angle is 30 degrees. Because that is in the sine quadrant, using our all stations to central, so it's in the sine quadrant, it would be equal to a positive sine of 30 degrees. Now we can use our exact value triangles. Sine of 30 is opposite over hypotenuse, which is going to be 1 over 2 again. Question C, tan of negative 3 pi over 4. First of all, let's change it into degrees. So I have negative 3 times 180, so replacing the pi with 180, all over 4 equals negative 135 degrees. So tan negative 135 degrees. Now a negative angle, when you're looking at your all stations to central, means that you're starting over here at 0 and you want to go backwards around the circle 135 degrees. So that angle in there is 135. We always want to find the angle to the horizontal. So if we do 180 minus 135, the acute angle in here is 45 degrees. All stations to central means we're in the tan quadrant. So tan of negative 135 is going to be equal to a positive, because it's in the tan quadrant, positive tan of 45. Tan of 45, using my 45-degree triangle over here, tan is opposite over adjacent. Opposite is 1, adjacent is 1. 1 over 1 is 1. And for D, last one of these, sec of 11 pi over 6. First of all, what is 11 pi over 6 in degrees? So we do 11 times 180 over 6 equals 330 degrees. Now, sec is not a trig function that we have exact values for, so we need to change that to the 1 over form. Remember, it's the third letter, so the third letter of sec is cos, so it's going to be 1 over cos of 330 degrees. 330 degrees would be in the fourth quadrant down here, and if we did 360 minus the 330, it would tell us that the acute angle is 30 degrees. Using all stations to central, that is the cos quadrant, which means that cos of something in that quadrant is still going to be positive, so it will be positive cos of 30. Cos of 30, using our exact value triangle, cos is adjacent over hypotenuse, so the adjacent is root 3 and the hypotenuse is 2. So it's 1 over root 3 over root 2. Obviously that's pretty yucky to have a fraction in a fraction. 1 over a fraction means that you turn the fraction upside down to be 2 over root 3. One last question here, number 5. Evaluate correct to 4 decimal places. Now this is just making sure that you can use radians on your calculator. So make sure that you turn your calculator into radians to type these in. So just a reminder on how to do that. You press Shift Mode and you press 4 to make sure that it's in radians, and you should see the little R up on the top of your screen. So all you want to do is type in cos of 2, press equals, and you want to write down the answer to 4 decimal places. So that's minus 0.4161. Then the other one, cot. Cot is a bit more of a problem. Cot is 1 over tan of 3.5, because the third letter is T, so it's tan, and then we'll type that in. 1 over tan of 3.5. You have to close brackets if it's in a fraction, otherwise it'll give you an error, equals, so that is 2.6696 to 4 decimal places. Okay, so I know you have quite a bit of work to do. Got 11G to work on as well, plus some of the early ones that I know some of you are catching up on.